afternoon to everyone. I'm Associate Professor Georgi Gadgev from National Institute of Geophysics, Geodesy and Geography in Bulgaria Academy of Science. And the topic of present talk is environmental pollution of air, description of Bulgarian system for operation of pollutant forecast. It is well known that the air quality has a key impact on the quality of life, human health, agriculture, climate change, and economy. The atmospheric composition fields are formed as a result of complex interaction of processes with different temporal and spatial scales, from global to regional to a chain of local scales. Earth's surface heterogeneous, including the complex terrain, have a significant impact on the atmospheric dynamics, hence on the formation of air pollution pattern. The incredible diversity of dynamical processes, the complex chemical transformation of the compounds and the complex emission configuration together lead to formation of complex structure of atmospheric composition. In this lecture, I will present a case study and some advantages and disadvantages of air pollution modeling. The structure of this lecture is following clarification regarding the meaning of emissions and concentrations, sources of air pollution, approaches in studying the air pollutions, advantages and disadvantages of meteorological modeling, case study, description of Bulgarian system for operation of pollutant forecast, and advantages and weaknesses of air pollution modeling. At the beginning, we have to make the following clarification regarding the meaning of emissions and concentrations. Emissions means the emitted amount of harmful gases or particles by sources for a certain time, and they are measured in tons, kilograms, or grams per year, day, and hour. Concentrations means the amount of harmful substance in a certain volume, and they are measured in milligrams per cubic meter or micrograms per cubic meter. In order to study the atmospheric composition, we need to know not only the meteorological condition, but also the actual spatial distribution, height, power, and type of the emission sources. As can be seen on the figure, the fields, waste, trucks, and automobiles can be interpreted as surface air pollution sources, while the houses and factories as large point sources. Airplanes as high sources, and etc. There are several approaches to study the air pollution. If our interest is only to know where a pollutant from a single source that was not subject to a chemical transformation would be spread, in this case, in order to solve the problem, it would be completely reasonable for us to use the Gaussian equation. But in real life, pollutants are undergoing a transformation, and for this reason, in the favor of scientists comes modeling, where many sources, pollutant species, and chemical reactions between them can be simulated over the large territories and under different meteorological conditions. In that case, it is necessary to have adequate data on the meteorological fields obtained by modeling of the atmosphere. Here someone can tell us why we should use modeling after modeling has some degree of inaccuracy, while observation gives us a real picture of time. Some benefits of using numerical modeling can be described as follows. Remove inaccurate and or false measurements, lack of data due to damage or theft of the measuring equipment. By using adequate methods and approaches for evaluating and tuning the numerical modeling, it is possible to make a relatively accurate meteorological forecast for several days in advance. At this slide is given an example of for advantages and disadvantages of observations and meteorological modeling. In mountain region, on one side of the mountain, rain can be measured equal to 100 millimeter and temperature 10 degree. On the other side of the mountain, the measured amount of rain is equal to 50 millimeters and temperature 15 degree. And at the foot of the mountain, the amount of rain is equal to 0 millimeter and temperature is 20 degree. In this case, depending on the location of the weather station, this will be reported without taking into account the other territories. While using numerical modeling, in this case, we will get an average if these three areas fall into one common grid cell of the model area, but we will lose information about the extreme local phenomena. Or we will get these three different values if the model area is fine enough, but this will increase the time it is take to perform the calculation. Case study for description of operation of Bulgarian chemical weather forecast system. The model used in the systems are well-known system US EPA models 3, which include WRF as a meteorological preprocessor in the system, driven by NCEP global forecast data GFS with surface resolution of 1 by 1 degree and 6-hour time resolution. SMOC is an emission preprocessor of the system, and CMAC is a chemical transport model, which use for input outputs from WRF and SMOC. The nesting capability of WRF are used to downscale the meteorological forecast from European domain with with 81 km big enough in order to correspond to GFA's meteorological data resolution, and for our domain, other domains are nested in it, and in each other Balkan Peninsula 27, Bulgaria, Sofia district and Sofia city are shown here. The chemical boundary conditions for Balkan Peninsula domain are calculated from specific climatic profiles, which comes with CMAC, and the chemical boundary conditions for Bulgaria domains are taken from the SILA model of Finnish Meteorological Institute. The weather research and forecast model WRF is a next-generation mesoscale numerical weather prediction system designed to serve both operational forecasting and atmospheric research needs. The WRF is a fully compressible and non-hydrostatic model with the rain-following sigma hydrostatic pressure coordinate with 27 vertical levels in our case. The grid staggering is a Bakava seed type. The analysis merging option four-dimensional data assimilation is switched on for the first computational domain only, Europe. WRF forecast is nudged to the meteorological driven data GFS. WRF offers multiple options that can be combined in any way, but the combination of them depends on many factors. Mostly in different parts of the world, the combination between different schemes has different performance. Here is shown some well-tried schemes for our domain or use, namely for microphysics we use WRF single moment 6+ scheme. For cumulus parametrization, we use Cambridge scheme. For planetary boundary layer, use Yonsei University scheme. For long wave radiation, rapid radiative transfer model scheme. For shortwave is Dudyaski, and for one surface model we use no one surface model. CMAQ demands its emission input in specific format, reflecting the time evolution of all pollutants accounted for by the chemical mechanism used see before in this case. Emission inventories are used as raw data for anthropogenic emission processing. The inventories are made on annual basis for big territories. Many pollutants are estimated as a group of pollutants, VOC and PM2.5, for instance. Preparation of emission input to a chemical transport model requires emission processing. Such emission processing component in the Model's tree system is small, but it is partly used here because it is quite strong relation to US emission sources specific. Smoke is used only for calculating biogenic emission and for merging area emissions, large point emissions, and biogenic emission files into a CMAQ emission input file. The area source emissions and large point source emissions are prepared by our interface program named IMIS and PMIS. For Bulgaria itself and for the other Bulgarian domains, the National Emissions Inventory, as provided by Bulgarian Executive Environmental Agency, is used. That means the TNO emissions inventory is used only for the territories outside of Bulgaria in the mother CMAQ domain. The TNO produced several sets of inventories for different years with resolution of 0.25 by 0.0625 degree. It's about 7 by 8 kilometer. The anthropogenic sources in the inventories are distributed over 10 snaps, classifying them according to the processes leading to harmful material release into the atmosphere. The pollutants are methane, carbon oxide, nitric oxides, sulfur oxides, non-methane volatile, organic compounds, ammonia, particulate matter with diameter smaller than 10 micrometers, PM10, and particulate matter with diameter smaller than 2.5 micrometers, PM2.5. As already stated, the inventory data cannot be used directly as an emission input to the chemical transport model. The following operation must be applied to this data preliminary. Grading, a web-based GIS system is created for this purpose. Temporal allocation, imposing of time variations on the yearly values, and speciation, splitting of group pollutant to several simpler or one pollutant. The graded inventories are input to the emissions processing of the programs IMIS and PMIS. The CMAQ output consists of various files containing concentration, deposition, visibility, and other variables. The concentration outputs is a netcdf file with three-dimensional hourly data for 78 pollutants, of which 52 gases, 21 aerosols in Aitken and accumulated modes, 5 aerosol distributions, 3 by number and 2 by aerosol area. First of all, the post-processing program extract part of the pollutant for archiving and future handling. Only surface values of the most important 17 pollutants are saved, 8 gases and 9 aerosols. As to make the result of Bulgarian chemical weather forecast system operational public, a special website was created on the server in our institute. For the moment, it presents 5 key pollutants: CO, NO2, SO2, ozone, and PM10. In additional maps of the time-space distribution of an air quality index can be displayed. Here the UK index is chosen as the one with best link to calculated and visualized pollutant concentrations. The air quality index presents air pollution level in 10 indexes and 4 bands according to the impact on the health of people who are sensitive to air pollution. In band low indexes 1 to 3, effects are unlikely to be noticed, and band moderate indexes 4 to 6, mild effect may be noticed amongst sensitive individuals, unlikely to require action. In band high indexes 7 to 9, significant effect may be noticed by sensitive individuals, and action to avoid or reduce this effect may be needed. In the last band, very high is index only 10. The effect on sensitive individuals described the high levels of pollution may be worsened. Here is given an example of the website of the system. The region of forecast can be chosen by clicking on one of these small images on the right side. In the center of the page, hourly concentration field of the chosen pollutant or air quality index is situated. Putting the mouse on the cursor on one of these points from point to point column to the right side of the images invoke the forecast field for the respective hour. Putting the mouse over the play leads to animation of the forecast. Under each pollutant images, respective thresholds according to Bulgarian legalization harmonized with the European law are shown. Under air quality index images, description of this index is placed. Here is the link of dominant pollutant air quality index images. At the bottom of the pollutant list, a link to a PDF file with description of Bulgarian chemical weather forecast is placed. Some examples of the advantages and weaknesses of air pollution modeling can be summarized as follows. An industrial operation may be propose a new facility. The emission can be approximately quantified using a model. These emissions can be fed into a model which can predict the emissions, especially around the sources. The models can be used to predict alternative situations. For example, the facility may decide to limit the production, to upgrade its infrastructure, change fuel, or install better, more efficient scrubber. The domain of atmospheric model, that is the area that is simulated, varies from a few hundred meters to thousands of kilometers with different motion methodology or phenomena occurring on each scale. Urban air pollution studies are simulated over a micro to meso scale domain. Regional acid deposition is simulated over a meso to synoptic scale domain, and global climate change studies are simulated over a global scale domain. The core benefits from addressing problems related to both climatic change and air pollution have been recognized. There is not much evidence comparing the mitigation cost and economy benefits of the air pollution reduction for alternative approaches to meeting greenhouse gas targets. Models are only as good as the data that you put in them, and they don't always reflect reality with total accuracy. They are, however, interesting in that you can answer questions and test scenarios which may be either impossible to test, like the impact of a new road or factory. They can also be used to assess questions which are too expensive to test with data collection, like air quality at a regional or global scale. Theoretical studies include analytical and numerical solutions to several appropriative equations that represent the physics of the pollutant downwind concentrations. These equations can be very simple or extremely complex depending upon the desired accuracy and the needed for estimating ground level concentrations. Obviously, without comparison with real-life data, the usefulness of theoretical model is limited. Experimental studies include field studies, studies in wind tunnels, and studies in water tanks, and they are too expensive. This is the lecture. I hope it was interesting for you, and if you have questions, you can ask me.
If someone can ask something, the professor can write the question in the chat, please, if there is no microphone.
Thank you.